Torque. In golf, it is a shaft's resistance to twist in degrees. It is measured by applying opposing twisting forces at opposite ends of the 46-inch shaft to get one data point. The lower the number, the more resistant to twist the shaft is. 2.8, 3.2, 3.6, 4.1. Golfers have associated these numbers with how the shaft feels, the launch and spin it produces, or what type of player it is for. Until now.
Traditionally, it's been about EI profiles in golf shafts. That's really what people gravitate toward when they think of golf shaft performance. It's the bending stiffness and how it changes throughout the length of the golf shaft. Sure, we can change the tip, the mid, or even the butt section. Each one of those plays a role in the overall performance of the product. What hasn't been talked about much is how the twisting in different sections will affect performance.
Introducing Fujikura's latest breakthrough innovation, Variable Torque Core.
With VTC, we're taking bending stiffness, torque, weight, swing weight within the entire length of the shaft and breaking that down into specific sections to create a performance that golf has never seen before.
The eureka moment for us where VTC became a big deal was when we did experiments on Enzo with different twisting profiles and with different materials in different locations and tried to understand what those influences were on things like direction or spin or club head acceleration. And each time we went through that analysis, the twisting profile became one of the largest levers. And it was something that we didn't expect. We've always been pushing bending profile. We've always looked at torque more as a singular number. Like, we've seen this 3 degree, 4 degree, 5 degree torque value of a shaft. It's not very descriptive, but so what we did was we wanted to look at it more specifically in different sections and then be able to tune that. And then again, the analytics came back and told us, wow, that's a really strong lever.
Club fitters have traditionally used golf shafts to modify launch and spin, and left-right direction was changed with the club head through movable weights.
Now with VTC, we're able to modify our designs to add performances variables like acceleration, velocity, and ultimately now direction.
Enzo has revealed specific points along the golf shaft that torque, bending stiffness, and weight can be adjusted independently to achieve never-before-seen performance.
We've got a very high-end motion capture system that helps us measure performance of the product in ways no one else can.
At Fujikura, Enzo testing allows us to see a different perspective on how that shaft is bending, deflecting, and twisting prior to impact. I can measure how much it's leading, which is going to change your dynamic loft, how much it's drooping, which is going to change potentially impact locations. And what we did was we created the gauntlet of prototype shafts which vary in different tip, mid, and butt stiffnesses, but also measure in different torque values. So what that allows us to do is to see what part of the shaft is having the biggest influence over ball flight. And that's the advantage that we have with our Enzo system over any of our competitors.
So in a typical golf shaft, we may have already 10 to 15 plies. Now with VTC, we could be more than doubling that. It's something we really want to do because VTC will open up another design space of creating a higher end performance products that just make the game more enjoyable and the performance there for every golfer.
In our rich history of over 50 years of golf shaft innovation and design, we've set the bar and set the standard on what technologies are. With VeloCore, with Enzo Analytics, and now with VTC, we're going to keep pushing forward to make golfers play better golf because that's our ultimate goal.
VTC, the next dimension of performance, only from Fujikura.